Thank you. As said, I am Andrea. I'm PhD student of University of Trento and Bruno Kessler Foundation. I'm here to talk about our work entitled Increasing Situational Awareness Through Nowcasting of the Reproduction Number. The main charter of this work are the nowcasting and the reproduction number. Okay, I don't know how to go. Okay, thank you. As probably we know that COVID-19 pandemic teaches us that epidemiological surveillance is a critical tool for policymaking because it helps to monitor the epidemic trend, in particular when the trend of the outbreak is increasing. You can see the figure in the left. We can compute parameters, which is important, the reproduction number that depends on the time. In that case, it is greater than 1. In the opposite cases, when the trend is decreasing, in the figure on the right, the reproduction number is less than 1. So there is a correlation between the values of these parameters, the trends of the outbreak, and the intervention that we want to investigate. Can we go ahead, please? Thank you. Okay, but how we can estimate these parameters? There are a lot of methods. In particular, we use a statistical method developed by Corey et al., which needs two ingredients. The generation time, which is defined as the time between the infection of the infector and the infection of the infectee in a transmission, in a chain of transmission. And in the figure, you can see an example of a distribution of the generation time for the Omicron variant estimated by Manica et al. The other ingredient is the epidemic curve, which is a time series. A time series of cases occur in a geographic unit. I want to say that we use the cases by date of symptoms because it is the time closest to the time of reporting of the infection, closest that we know. But so once we have the generation time distribution, the only thing that we need is the epidemic curve. But using this type of time series by date of symptom onset, we have some problems. For instance, due to the reporting delay. For instance, look at this example of a reporting process. You get the symptoms today, Tuesday. You take the test tomorrow, and okay, it works now. No. Okay, and you get the result of the test on Thursday, but you will be updated in the dataset on Friday. So there are 3 days of delay. And you can see that it implies that there is an underestimation of the cases near to the date of analysis. In the figure in the left, in the red rectangular. So if we estimate the reproduction number with this data set, we have an underestimation of the reproduction number. It is called, right truncation, sorry. So what we can do is nowcasting. The nowcasting is defined as the real-time assessment of current situation according for underreporting. We propose a method of nowcasting in which we assume that for date of symptom onset enough distant in the past respect to the date of analysis, the data are consolidated. So what we did is, I don't want to enter much in mathematical details. The idea is quite simple. You fix the time of symptom onset, look at the time of reporting, and you investigate the behavior of the trend, you normalize, and you repeat these procedures several times, and after that you average. The result is this. Take just the idea. If you want more details, there is the paper at the end. what you obtain is this function called consolidation function. By using this function, we can augment the data set, but there is also other information with this function. For instance, what we can say that how many days we have to wait to reach the 70% of data completeness. In this case, are 1 week, 7 days. And what we did with this method, we create the nowcasted data set. In the figure in the left, you can see 3 different time series. The consolidated one with in the gray triangulars, which is the time series available 2 years later. You don't have in the real time in the real time. The nowcasted one, the time series obtained by using our method, and the observe, the time series that you have in the real time. You can see that in this case, it works very well. And moreover, there is a correlation between data completeness, maybe before the data completeness, and the delay, the time that you have to wait to reach this data completeness. So using these 3 types of data set, we computed the reproduction number. So we have 3 different reproduction number, and we investigate which is the distance, between the reference ones nowcasted and the reproduction number obtained by using the observe time series. So let's talk about a little bit about the result. In the figure in the left, you can see the distribution of the absolute error changing the data completeness. So remember, when I say data completeness, there is a correlation with the delay. I think that what we can say most important is that taking into account the 70% of data completeness with the nowcasted method, we have the same absolute error in medium with using the net time series, using the reproduction number, using the time series of observed cases. After that, we investigate the over and the underestimation. And you can see that using the net reproduction number, we underestimate the most of the time for each data completeness. Instead, using the nowcasted one, we have half times that we underestimate and half time that we overestimate. For statisticians, if you look at the absolute error, if the distribution is symmetric, and accounting also with the figure in the center, we can say that the nowcasting method is unbiased, but the distribution is not perfectly symmetric. The third result is about the proportion of the times that we are closest to the reference reproduction number, comparing the net and the nowcasted, changing also the data completeness. The times that we are closest using the reproduction number with respect to the net one is about 80 and 90%. The last results are about the detection of the outbreak. There is a definition when we consider an outbreak that it is increasing. We look at 5 periods of this type in which the reproduction number is greater than 1, so we need some intervention. And what we can say is that using the nowcasting method, we can anticipate the detection. In the figure in the left, we use the 90%, so we have to wait 11 days. In the figure in the right, we change also the data. We can see changing the data completeness, and once we can say that okay, we decrease the data completeness, so we can anticipate the detection, but be careful, because look at the next reproduction number in blue. you can be in the situation in which you cannot observe the detection of the period. So, yeah, thank you. I want to thank all the people that contribute to our work. It is published, and they come from FBK, the ISS, and the University of Bocconi, and the University of Indiana. The main message that I want to give to you is not this is our method, it is the best method, because there are a lot of methods of nowcasting. The message is there are some methods that can help us to investigate and help the authorities, and maybe we can use it if they are checked. Thank you.